Hello and welcome back to Mrs. Ogram's Maths. Today we are looking at a work solutions video for the Level 2 Calculus paper from 2020. Let's get stuck in. So for question 1 we've got f of x. We want to find the gradient at a particular point. To find the gradient we differentiate. Now if you're ever not sure what to do on a question on this paper, just differentiate the thing that you have been given. That is most likely the thing that they're asking you to do. So let's take that function and differentiate it like so. And we want the gradient when f is 4. Now a little tip, when you go to putting this into the calculator, make sure you use the brackets. Oh, I've just realised I made a mistake on that one. So that was 4x rather than 4x squared. So when we pop that in the calculator, it will look like this. So we'll have 3, then put that thing into the brackets because it's easy to make mistakes with negatives. And if you include the brackets, then you'll always get that right. Okay, so we've got the gradient is 32. Right, part B. Another function is given by this one here, h of x. Find the x-coordinate of the point on the graph where the gradient is equal to 5. So same again, we need the gradient function. So 2 times 0.5 is just going to be 1, so that'll be an x, and then plus 3. And we want to do that where the gradient is equal to 5. So set that equal to 5, and then x must be 2. For part C, we find the equation of the tangent to the curve at that particular point. So we will use the function or the equation y minus y1 equals mx minus x1. You might also be used to doing y equals mx plus c. I prefer this version now that you're slightly more sophisticated in your maths language at level 2. It's a little more straightforward than y equals mx plus c and just 1 or 2 steps less, so less chances to make errors. Right, to do this we need the gradient, so dy by dx will be equal to 2x plus 5. When x is 2, because the x-coordinate of this was 2, dy by dx, so 2x plus 5 would equal, well, 2 times 4 plus 5 makes 9, so the gradient is 9. Now put it into our equation setup. So the y minus y1, our y coordinate is 14, equals m, which was 9, x minus the x coordinate, which is 2. So y minus 14 is 9x minus 18, or y is 9x minus 4. Right, part D, the gradient function of a curve is given by this one here. P is a constant. That means it's just a number, but we don't know what the number is. And it passes through these 2 points. Find the equation of the curve. So we've been given the derivative. We need to go backwards to find out what f of x is. So we are integrating that function, or your teacher might refer to it as anti-differentiation. I don't really like that term because we have a proper word for it. It's called integrating. So what would that have to have been to make px? So it would have needed to be 1 higher power of x, and that p would have got multiplied by 2 when it was differentiated. So this would need to be p over 2. Or you could write that as px squared over 2 like this. And just do a mental check that when you differentiate that, it does become px. Then we'll have minus 4x and a constant that we don't really know just yet. Right, so then we've got some information that we can use to work out the bits that we don't know. So when x is 4, y is 12, or f of x is 12. So let's pop that in. So we've got 12 equals p times 4 squared over 2 minus 4 times 4 plus c. Simplifying that is going to look like this. So c is equal to 28 minus 8p. Right, the other bit of information we have is that is this other coordinate here. So when x is minus 6, f of x is 2. So 2 equals p times negative 6 squared over 2 minus 4 times negative 6 plus c. And again, sorting that out, we get c is minus 22 minus 18p. So we've got c is equal to this, and c is also equal to that. So if we set them equal to each other, we can work out p. So 28 minus 8p is equal to minus 22 minus 18p. You can use equation solver on your calculator if you like, but that one doesn't take too much tidying up. We get that p is minus 5, and if we put that back into one of the c values, we can work out c. So if p is minus 5, c is equal to 28 take away 8 times minus 5, which is 68. Now just go back and check what we were asked to do in the question. Find the equation of the curve. Okay, so we had the equation up here. Now we just need to write that with p and c in it. So f of x is equal to px squared over 2, so p is minus 5. So minus 5x squared over 2 plus, oh actually it was a minus, so now here the minus 4x and then the plus c. Minus 4x plus c, which is 68. Okay, E. This will be the excellence question. We've got a fishing boat 80 kilometers from its port. We've got some information about acceleration and so forth. So we're using kinematics here. We've got the acceleration. We know the speed of the boat was 3 when it starts fishing. During which hour did it travel? 11.75 kilometers. Okay, so we're going to use some kinematics here. Now our starting point is that we have the acceleration, and where we want to get to is a distance, so we can work out what the t value is for this distance. So first of all, we're going to need to step through to the equation for speed, so that's the velocity equation, and we're going to integrate the acceleration to get the velocity. So that'll be 0.5t plus a constant. Now we know this information here, the speed of the boat is 3 when it starts fishing. So v when the time is 0 will be equal to 3. So 0.5 times 0 plus c equals 3, therefore c is equal to 3. So the speed that we get from velocity we'll do by integrating the velocity. So that'll be 0.5 t squared over 2. Now remember the c gets replaced with the 3, we just worked that out. So that'll be 3t plus c. Now to work out that value of c, we use this information that we've got here. At the time that we start recording time in this situation, it's when they start to accelerate away from the port, having reached the fishing ground. So at that beginning point, they have already started at a distance of 80. So when the time is 0, the distance will be equal to 80. So 0.5 0 squared over 2, 3 times 0 plus c will be equal to 80, therefore c equals 80. Now the final piece of the puzzle, during which hour do they travel an additional 11.75 kilometers? So if we're thinking about our function, so the hour that we're looking for, take away the previous hour, so the distance traveled in the previous hour, that difference will be 11.75 kilometers. Okay, so s of t looks like this, and then we can subtract s of t minus 1. And that looks like this. It's just the same, but I've got t minus 1 instead of t in there. And we set that equal to 11.75. So the hour that we're on, take away the distance traveled in the hour just before it, will equal 11.75. Now use your calculator, you don't need to do that tricky algebra there. Equation solver, and I'll just show you where I got there. So F3 for equation solver. I've typed the whole lot of that into there and hit solve, and then we get x equals 18, or in this case t equals 18. So in the 18th hour. Okay, moving on with question 2. I've just added a little switch of mic because the other one was sounding a little muffled, so hopefully this is a bit better for you. Okay, so we've got the graph of this function on this picture below. We want to sketch the graph of the gradient function of that curve on the axis beneath it. Okay, so I'm going to just shrink this down to have a look at what's going on both of these. Right, so the key points are we've got the gradient is positive here, decreasing towards this bit here. When we have a stationary point, it's equal to 0. So that's a point I can plot straight away. So this same x value here will have a gradient of 0. So down here, we will put that it hits the x-axis there. It will be positive up to that point, and it starts off as a high steep positive and then shallowing off, shallowing down to not quite as steep positive, like so. Now this curve we've started with is a cubic, so the gradient curve we're going to end up with should be a quadratic. In other words, a parabola. So it's going to be positive, getting smaller positive like so. It's going to hit that point there. Now I might tidy that up after I've put in some more of the graph. We'll see how we go. Okay, so then this stationary point between these two, we've got a negative gradient. It starts off fairly shallow, gets steeper, gets shallower again until we get 0. So we've got negative until we hit, again, this same point here would have a gradient of 0 down here, and then after we get that stationary point, it starts off shallow positive and then steeper, steeper, steeper positive. Okay, so small positive, bigger, bigger, bigger like this, and that middle bit in between, let's see if we can complete that now, would look like that. Now one small tip, if you are trying to draw curves, it's easier to do it from underneath the curve, so if you turn your paper upside down, you can make that one a bit smoother. Okay, on to part B. Find the x-coordinate of the maximum point on this particular curve and explain how you know that it's a maximum. So start by differentiating y. We get 6x squared minus 84x plus 240. Now stationary points happen when that is equal to 0, so we set that equal to 0. If we take out or divide through by 6, we can get x squared minus 14x plus 40 is equal to 0. So then if we factorize that, we get x minus 4 and x minus 10. So the stationary points happen at 4 and 10, and we just need to work out where the maximum is of those. So I'm going to use the second derivative. So the second derivative is 12x minus 84. When x is, let's test out the 4, d2y dx squared will be equal to 12 times, oops, I'm in the wrong menu, hold on. There we go, 12 times 4 minus 84 is 36. That is less than 0, therefore it's a maximum. We found the one we want. Okay, C, we've got the speed of the object, so we're looking kinematics again. We want the acceleration. So acceleration is differentiating speed, so that will be 6t minus 5. So that acceleration when t is 2, 6 times 2 minus 5 is 7. Easy. Okay, for part D, we have got the graph of the gradient function is given to us in this picture. The point C0 is on that graph. Sketch the graph of the function itself. So it's kind of the opposite way around to the one we've already done. And we will put what that could look like below. So let's break down some of the information that we've got. The gradient function is a negative parabola. It's a negative x squared type thing. So the function that came from
would be, or rather I'll write it down here, negative x cubed. Some sort of constant would be involved there. So this could be like a negative a in front, this could be a negative b, but we're not interested in the constant itself, we're just looking at the shape of it. So a negative parabola for the derivative means we've got a negative cubic function, so it will go sort of like that, something like this. Now we also know we've got this point C where the gradient is equal to 0 here. We've also got the gradient equal to 0 there, and the gradients are equal to 0 when we have the turning point. So it'll be these 2 points on our graph. Now one more bit of information we have is just here, f of c is equal to 0. It's easy to miss that piece of detail just there because it was underneath the graph. So our graph will actually go through this point C because the y value will be equal to 0 when x is c. So we have a minimum at c and it goes through that point C. So we can fill in that part of the curve. I'm going to do that again, hold on. Something like this, and like I said earlier, it's easier to draw curves from underneath, so if you turn your paper over you might find that a little easier to do. Okay, then we have a maximum over here at this point where the derivative was equal to 0 here, the gradient function was equal to 0, so our maximum will be somewhere over here, so something like so. And it should have some sort of, you know, reflective symmetry there, or rotational symmetry if you like. So if I had the means to do this properly on paper and pencil, I would probably redraw that one a little wider like this, just to match the wideness of the rest of the graph. You do get given a little leeway on your drawings there so that it's just got the general idea of what it needs to be. Okay, and finally part E for this question, we've got this cubic function. We're told that it's got turning points at x is 3 and x is minus 5. Find an expression for C in terms of A. Okay, so we want to get C equals something with A's in it at the end. That's what that means, C in terms of A. Okay, so let's work through what we've got. Cubic function is f of x. We are told about turning points, so we're going to differentiate that thing. So that'll be 3ax squared plus 2bx plus c. We know that that equals 0 when x is 3 and x is minus 5. So f dash of 3 is 3a 3 squared 2b times 3 plus c. That will equal 0. Also f dash of negative 5. 3a of negative 5 squared 2b negative 5 plus c will also equals 0. So tidying up that first one, the f dash of 3, we will get 27a 6b plus c is 0. And then the f dash of minus 5, if we tidy that up, we've got 75a minus 10b plus c is 0. Now remember, we want c in terms of a, so we want to try and eliminate the b's out of this if we're doing solving simultaneously. So let's see, we can multiply up. Now there are a couple of ways we can do that. Probably the most obvious one would be to make those both into 60b. So to make 6b into 60, we times it by 10. So that whole line times by 10 would look like this. And the second line, we times all of that by 6. And then add the two together. And then rearrange, so we've got c equals something in a, so c is equal to negative 45a. And now moving on with question 3. We've got f dash of x is this function here. It's the derivative of f, and it passes through this point. Find an expression for f of x. So we are integrating. F of x will then be raise that power to 3 and divide by the new power. So 3 divided by 3 is just 1, leaves us just with x cubed. Similarly, x becomes x squared, and if we divide 2 by 2 we will just get the negative 1 there, and then minus 4x and a plus c. We know that when x is 3, y is 10, so f of 3, that's 3 cubed, minus 3 squared minus 4 times 3 plus c will equal 10, so therefore c has got to be 4. So f of x equals x cubed minus x squared minus 4x plus 4. On B, we've got a whale that surfaces on a still sea. As he surfaces, a circular ripple expands outwards at a constant speed. We've got the radius of the circle is given by this function here. At what rate is the area of the water within that ripple increasing 20 seconds after it surfaces? So let's start with what we've been asked for, the rate of the area of water. So dA by dt is what we're looking for. What we know is that that area is going to be pi r squared. So dA by dr will equal 2 pi r, so just differentiating that. So we've got dA by dr, but we want dA by dt. We need to use the chain rule to work out how to get from dA by dr to dA by dt. So we need to multiply by a dr on the top and a dt on the bottom, so that this dr would cancel with that one and we'd be left with dA by dt. So we've got one part of that. Now let's pick out the dr by dt. So we're told that r equals 0.7 t. So dr by dt will equal 0.7. So dA by dt will be dA by dr, so 2 pi r, times by dr by dt, 0.7. And we want to work that out when t equals 20. So we actually need r in terms of t. So if we replace that r with 0.7 t, so when t is 20, dA by dt will be 2 pi 0.7 times 20 times 0.7. So that is 61.58, and we'll pop the units in. We are measuring in meters, so that area will be meters squared, and the time was per second. Part C, we've got the graph of the quadratic function h of x at the top, together with its gradient function here, h dash of x. Find an expression for h of x. So we need to read off the information we've got from this graph to be able to get those details. Okay, let's start with the equation of h dash of x. We can get that from the intercepts that we have of this line. So I'll use y equals mx plus c. The gradient is rise over run, so that's 2 over 3, and it's negative. And the intercept is 2. So this will be negative 2 over 3x plus 2. Now we can integrate that to get h of x. So increase the power by 1, divide by the new power, so that will become a third rather than 2/3. 2x and a plus c. Now we know that when x is 0, y is 4 from this one here. So h of 0, so minus a third, 0 squared plus 2 times 0 plus c will equal 4, so therefore c equals 4. And h of x finally is negative a third x squared plus 2x plus 4. Right, next we've got this function f of x. It's got a tangent of that has a gradient of 15 when x is 2. Find the value of k. So let's differentiate because we are looking for gradients of tangents. So that will be 3k x squared plus 9. We know that when x is 2, that's equal to 15. So 3k times 2 squared plus 9 is 15. 12k plus 9 is 15. So 12k 15 take away 9 is 6, so k is equal to a half. Okay, last one. Part E here for an excellence. Just pause the video and have a read of that. Okay, so we've got different triangles that can be made within here. We want to find the maximum possible area. So first of all, we need an expression for the area. So area would be half the base times height. But we need that expressed in terms of x. So the base will be the x coordinate, because wherever your value of x is, so if you've got your coordinate a here, your x coordinate will give you the distance away from the origin. So it'll give you the base. Now the height will be the y coordinate, which is worked out by mx minus x squared, because that's the expression for y. So if we expand that, we get half mx squared minus half x cubed. Now to maximize things, we need to differentiate. So dA by dm. We bring the 2 down with the half, that multiplies through to 1. So we get mx minus, and then bring the 3 down, times it by the half, 3 over 2x squared. Now we find maximums when that derivative is equal to 0. Take out a factor of x, so we can solve it, and it's looking like this. So either x is 0 or m minus 3 over 2x is 0. Well, that's not going to give us our maximum area, because if x was 0, it would be this point down here on that graph. It's going to give us a 0 triangle. That's definitely not the maximum area. So then continuing on with this other bit, 3 over 2x would equal m, so x equals 2/3 of m. So just be careful, it's tempting to stop there and feel like you're done. What we've done is found the x coordinate that would give us the maximum possible area, but now we actually need to find that area itself. So when x equals 2/3 m, the area will be equal to half times, now remember we've already got this up at the top here, so half times 2 over 3m times m 2 over 3m. So let me write that a bit better. So m times 2 over 3m is going to be 2m squared over 3 minus 2m over 3 squared. Okay, now let's tidy that up a bit. So we'll have a third m, 2m squared over 3 minus 4m squared over 3. Wait, no, that's not over 3, that's over 9, because that got squared as well. Now 2/3 take away 4/9 will be 2/9 m squared inside that brackets, multiplied by 1/3. So that's going to be 2/27. So 2m cubed over 27, because the m also gets multiplied through there by the m squareds. All done.